Tonight, we drift into a question so colossal, so slippery, that it feels less like science and more like a dare whispered in the dark. What if Earth isn't near a black hole at all, but already inside one? It's the kind of thought you only let loose at 3 a.m. when sleep is distant, when the mind cracks open to possibilities it usually slams shut, half joking, half terrified. And yet, the longer you let it linger, the less it sounds like fantasy. What if those invisible prison bars have been wrapped around you all along, unseen, unquestioned? You let yourself sink back into the night now. The stars above don't look like mere glitter anymore. They look like clues, breadcrumbs scattered across a cosmic labyrinth, pointing at something stranger than comfort can hold. Even the air feels different when you toy with this idea, heavier, as though time itself has thickened, slowed, waiting for you to notice. Here's your first warning. If Earth really is inside a black hole, this isn't just a curiosity. It's a thought experiment sharp enough to leave marks on your sanity. But tonight, you're safe. I'll keep it gentle, strange enough to stretch your imagination, soft enough to fall asleep to. Before we go further, a small request. If you enjoy these journeys into the deep, these long drifts into cosmic possibility, then consider joining me here again, only if it feels right, of course. Now breathe. Let the lights dim. Let the question carry you. You move forward in your imagination, past the last street lamp, past the thinning atmosphere, until Earth shrinks behind you. The black expands. And what is a black hole, really? Not just a cosmic vacuum cleaner, not just a hungry mouth. No, it's reality folded in on itself, geometry rewritten, time shackled. Scientists call them gravity's apex predators. And if the monster is not out there, but here, then you are not a distant observer. You are already inside its belly, mistaking its cage for freedom. That's not just clickbait. Physicists, serious ones, have wondered whether the entire observable universe might be nothing more than the interior of a black hole. To us, it feels infinite. To something outside, it might be a bubble, a speck, an invisible bead of collapse. A chill flickers through you when you let that sink in. Suddenly, the night sky doesn't feel like a window. It feels like a wall. Ancient cultures must have felt something similar. The Mayans imagined stacked layers of the underworld, hidden beneath the surface. The Greeks puzzled over invisible spheres that held the stars in place. They didn't have Einstein's equations, but the intuition that we live inside something larger than we see has haunted humans forever. It's not all grim. Picture the irony. Humanity builds telescopes capable of peering across billions of light years, straining to see the edges of reality, while all along we might already be sitting in the attic of the haunted house we're trying to map, searching for the beast while nestled safely in its ribs. That's not just clickbait. Physicists, serious ones, have wondered whether the entire observable universe might be nothing more than the interior of a black hole. To us, it feels infinite. To something outside, it might be a bubble, a speck, an invisible bead of collapse. A chill flickers through you when you let that sink in. Suddenly, the night sky doesn't feel like a window. It feels like a wall. Ancient cultures must have felt something similar. The Mayans imagined stacked layers of the underworld, hidden beneath the surface. The Greeks puzzled over invisible spheres that held the stars in place. They didn't have Einstein's equations, but the intuition that we live inside something larger than we see has haunted humans forever. It's not all grim. Picture the irony. Humanity builds telescopes capable of peering across billions of light years, straining to see the edges of reality, while all along we might already be sitting in the attic of the haunted house we're trying to map, searching for the beast while nestled safely in its ribs. History teaches us that speculation often wins. Once people believed Earth was the immovable center. Then Copernicus nudged it into orbit. Einstein bent that orbit with relativity. Each time, the cosmos revealed itself to be stranger, harsher, yet more wondrous. The next twist could be this: that your every breath, your every heartbeat, takes place inside the hidden interior of a black hole. And that's true, then the stars above aren't a ceiling of endless freedom. They're the paint on the walls of a cell, so large you can't see the bars. You probably won't sleep right away, but that's the point, isn't it? To drift in curiosity, even if it takes you somewhere you can't quite escape. You've stepped across the threshold now. The night is wide and velvet around you. And before you can even begin to entertain the suspicion that you might be inside a black hole, you need to know what a black hole truly is. Not the movie version, not the neat little funnel diagrams on posters. The thing itself, the stubborn, terrifying creature that Einstein's equations predicted and nature, against his doubts, delivered. At its simplest, a black hole is gravity gone rogue. Imagine a star heavier than the sun, burning through its life like a great cosmic bonfire. Hydrogen, helium, layer after layer of nuclear fuel until the fire runs out. And then gravity wins. The star collapses inward, tighter and tighter, until nothing can resist the squeeze. Eventually, the collapse becomes so absolute that even light, the fastest, most stubborn traveler in the universe, cannot escape. That's when a star earns its shadow crown. That's when it becomes a black hole. The name is misleading. A black hole is not a hole in any ordinary sense. It isn't an empty gap. It's a region of warped space-time, a place where the rules of geometry have been rewritten. To fall into one is not to fall into emptiness. It is to fall into the very bones of reality, twisted beyond recognition. Cross a certain line, the event horizon, and you are gone. To the outside universe, you freeze. Your signals stretch into red and fade. But to you, on the inside, time keeps flowing. You fall forward, not down. Forward toward the singularity, the point at the center, infinitely dense, infinitely small, where the equations of physics throw up their hands and stop working. This is not just a metaphor. Spaghettification is an actual term in astrophysics. If you fall feet first, your ankles are pulled harder than your head. You are stretched thin, unraveling atom by atom until you are cosmic pasta. Stephen Hawking once quipped that should you tumble into a black hole, you might be immortalized as a faint glow, a strange consolation prize, radiating faint whispers as Hawking radiation. For a long time, even Einstein doubted black holes could exist. He had birthed the mathematics that allowed them, yet he found the idea too monstrous. Surely nature would forbid such extremes. But by the 1960s, the evidence mounted. Quasars shining from the early universe, stars whipping around invisible partners, gravity that could only be explained by something hidden, dense, and dark. And today, we have photographs, grainy yes, but undeniable, of their fiery rims. Cosmic predators finally captured by human eyes. But black holes are not just monsters devouring unlucky stars. They are also anchors. At the heart of the Milky Way, the galaxy you call home, sits Sagittarius A star, a supermassive black hole 4 million times the mass of the Sun. Without it, the galaxy's stars would not whirl in their graceful spiral. Without it, your night sky would scatter differently. You owe your galaxy's architecture, your very stargazing vantage point, to the invisible pull of a gravity beast sitting quietly 26,000 light-years away. And yet, even knowing this, the idea of inside is slipperier than your mind wants it to be. What does inside mean when time itself has been inverted, when space collapses? Inside a tent, inside a room, those are places. Inside a black hole is not a place. It is a fate. To cross the horizon is to surrender every tomorrow to the singularity, to age inward, to be carried by time itself toward a core you cannot avoid. And here's the rub. From the outside, no one ever sees what happens inside. The horizon is absolute. Information does not return. To those who remain, the interior is sealed. Which means, from our perspective, the inside might as well be another universe. Unless, of course, we are already there. The thought gnaws at you because it rhymes with something you already know. Astronomers say you can't see forever. You can only see as far as light has traveled since the Big Bang. That boundary, your cosmic horizon, is eerily similar to the event horizon of a black hole. It's the line beyond which nothing reaches you. Your universe is bounded, just like the interior of a black hole. And here's the gentle twist. Black holes don't suck in everything nearby like some cosmic vacuum. If tomorrow the Sun were swapped for a black hole of the same mass, Earth would continue orbiting almost exactly as before, cold and lifeless without sunlight, but not swallowed. Black holes only turn catastrophic when you venture too close. Which means that imagining the universe itself as the interior of one doesn't mean doom. It means subtlety. A prison so large you mistake it for infinity. It's a thought you can't shake, a universe expanding, horizons fixed, time dragging you forward. You trace the idea with your fingertip in the dark, restless, unable to let it go. The cage is invisible. The cage is everything. And the irony? A century ago, black holes were mathematical ghosts. Today, they're astrophysical reality, which means the leap from they exist to we might live inside one isn't lunacy. It's simply the next step in a long tradition of discoveries that began as heresy and ended as fact. The path ahead is darker now, but your imagination, for better or worse, is steady. And the next question rises inescapable. If the universe is a black hole, how big is it? You're further in now, drifting with the thought, as though gravity itself has claimed you. If black holes are real, if they're not just mathematical rumors but actual objects lurking in the dark, then the question sharpens: what would it mean for Earth to be inside one? To answer, you need to feel the weight of scale, the absurdity of numbers, the way black holes bend not just space, but your imagination. Start small. A black hole's size is defined by its Schwarzschild radius, the radius of the event horizon where escape becomes impossible. For something the mass of Earth, that radius would be less than a centimeter. Imagine it. All of Earth, mountains, oceans, dogs, skyscrapers, your messy desk, squeezed down to the size of a marble. A marble heavy enough to drag the very floor into itself. A marble you could almost lose under your couch cushion, but one that holds the crushing pull of an entire planet. Now flip it. Imagine Earth not as collapsed, but as already inside a black hole. How large would the prison need to be? For the observable universe to mimic a black hole structure, its Schwarzschild radius would need to match its visible size, roughly 46 billion light-years across. That's the size of the cosmic bubble you can see with telescopes. Not infinite, not boundless. A finite bubble vast enough to cradle every galaxy, every star, every Tuesday morning coffee. Here's the irony. In such a black hole, the density doesn't crush. It feels normal, comfortable. You don't wake up stretched or flattened. You don't notice anything wrong. The cage is simply too large. To you, the ground is solid. Time ticks evenly. The stars scatter in familiar patterns. The monster's grip is invisible because it is everywhere. This idea isn't new. Back in the 18th century, an English clergyman named John Mitchell speculated about dark stars, objects so dense that light itself could not escape. He didn't know relativity, he didn't know about singularities, he just played with Newton's gravity and scribbled by candlelight. Centuries later, his thought experiment mutated into what we now call a black hole. A universe-sized trap was already hiding in his equations. Modern physicists have noticed something eerie. The average density of the observable universe is suspiciously close to the density required for a black hole of its size. Imagine walking into a room, measuring every wall, every corner, and realizing the dimensions match the blueprint of a cell. You never noticed the lock before, but the math suggests you're not in a room, you're in a prison. So what does it feel like? That question clings like static. You look around. Time moves forward. Your coffee cools too quickly. Your phone battery drains faster than it should. Nothing screams black hole. And yet, you remember. Inside a black hole, time itself is warped. To an outside observer, you would appear frozen. To you, life feels normal. Expansion, acceleration, galaxies fleeing one another. Maybe what cosmologists call dark energy is nothing more than the geometry of the trap, the hidden shape of the interior. Picture it like this. In a stellar black hole, time dilates near the horizon. An observer outside sees you slow, sees you stretch. To you, time ticks on as usual. If the universe itself is inside one, maybe what astronomers measure, the acceleration of expansion, isn't caused by exotic energy at all. Maybe it's the signature of falling inward, misinterpreted as rushing outward. Not everyone buys it. Some physicists argue that comparing the universe to a black hole is like comparing a loaf of bread to a brick. Sure, they look similar until you try to build a house with them. The analogy holds only so far, but the itch remains. Scale has always mocked human comprehension. Compress Mount Everest into a black hole, and it would be smaller than a proton. The sun, shrink it to 3 kilometers across. And the observable universe, a bubble whose event horizon matches its own size exactly, which means you never see the bars of the cage because the cage is all you have ever known. Here's a cheeky thought. You've worried about laundry socks going missing, but maybe the real laundry problem is cosmic. Maybe your whole life is being tumbled in the spin cycle of some unimaginable black hole, the invisible dryer whirring around you while you mistake the noise for silence. And so, the next time you look up at the stars, ask yourself, are you gazing out into freedom? Or are you pressing your nose against the inside of glass, staring at walls so distant you've mistaken them for infinity? The thought doesn't let go now. The scales match, the cage is invisible, and you find yourself wondering, what does the math really say about all this? You don't need to drown in chalkboards filled with Greek symbols, but you do need to touch the bones of the equations, the way Einstein's work seemed to whisper, yes, this could be possible. At the heart of the story sits general relativity, Einstein's masterpiece. Instead of describing gravity as a mysterious pull, he told us to think of it as curvature. Mass bends space-time, and everything else moves along those bends. Imagine laying a bowling ball on a trampoline. The dip it makes is the sun, and Earth simply rolls around the curve. Now imagine the bowling ball so heavy that the trampoline folds in on itself. That's a black hole. In 1916, just a year after Einstein presented his theory, Carl Schwarzschild found a precise mathematical solution. His formula showed that if you compress a given mass inside a critical radius, the Schwarzschild radius, you get an event horizon. For Earth, that radius is less than a centimeter. For the Sun, 3 kilometers. For the universe itself, suspiciously, it lines up almost exactly with what we observe as the cosmic horizon. That's not a coincidence you can shrug away. The same equations that describe collapsing stars can also describe an entire expanding universe. The geometry looks almost identical. It's as though the blueprint for a black hole doubles as the blueprint for reality. Historians still debate whether Georges Lemaitre, the Belgian priest who first proposed the primeval atom, what we now call the Big Bang, ever noticed the resemblance. He imagined a universe born from a point, expanding outward, a collapse in reverse, a singularity blooming instead of crushing. Was he unknowingly brushing against the idea that black hole interiors and universes share the same skeleton? Fast forward to the modern era. In 2010, some physicists suggested that when a star collapses, it may not crunch into a singularity at all. Instead, space-time might bounce, like dropping a ball on a floor. On the other side of that bounce, a new universe could unfold, which means our Big Bang might not have been the absolute beginning, but the inside-out birth of a collapse somewhere else. A cosmic nesting doll, universes tucked inside black holes, each one giving rise to another. And what does inside really mean here? Beyond the event horizon, time and space flip roles. Crossing the boundary doesn't feel like stepping through a doorway. It feels like surrendering to a new law. Time doesn't flow toward tomorrow anymore. It flows toward the singularity. You don't walk inward, you age inward. Every breath, every blink is a step closer to the core. If our universe is inside one, then your entire existence is part of that inevitable fall. But here's where it gets even stranger. From the outside, what looks like collapse can, from the inside, look like expansion. Two descriptions of the same event depending on your vantage point. To us, life feels like galaxies rushing away in a cosmic explosion. To an observer outside, it might look like matter collapsing into a black hole. Both are valid, both are real. Two sides of the same coin, one labeled universe, the other black hole. This is where the arguments flare. Some scientists insist the equations are incomplete. They don't account for quantum mechanics, the jittery world of particles that refuses to sit still. Without quantum gravity, we're scribbling on half a chalkboard, filling the rest with guesses. So, when the math rhymes, when black holes and universes echo one another, skeptics argue we may be staring at coincidence, not truth. But the allure is undeniable. The IKEA analogy works here. Imagine two pieces of furniture built from the same blueprint. One is labeled wardrobe, the other dungeon. You squint at the diagrams, they look identical. Are you reading them wrong, or are both true at once? That's the puzzle physicists face when they realize the equations for black holes and expanding universes overlap almost perfectly. Here's the irresistible thought. If universes can bloom inside black holes, then what if ours already did? What if you, lying here now, drifting toward sleep, are not just floating in space, but tumbling through mathematics itself? Every second carrying you deeper into a singularity that, from your point of view, looks like galaxies rushing outward in every direction. The cage might not just be real, it might be written into the very equations you trust to describe reality. You are lying there now, caught in the dark like a mote suspended in a beam of light. And the question sharpens into something even bolder. What if the entire universe, all of it, every star, every galaxy, every fleeting human thought, really is the inside of a black hole? Not just Earth, not just a patch of sky, but the whole cosmos itself. At first, it sounds like late-night science fiction, the kind of claim you'd expect from a radio host with too much coffee. But the unsettling truth is that sober physicists, equipped with chalkboards, patience, and nerves of steel, have entertained the idea for decades. The observable universe, they argue, behaves uncannily like the interior of a black hole. The expansion, the horizon, the density, everything hints at a cosmic trap masquerading as normality. Start with the horizon. Every black hole has one, the event horizon, the no-return line beyond which information cannot escape. Our universe has something eerily similar, the cosmic horizon. Beyond it, light hasn't had time to reach us since the Big Bang. To you, it's the edge of sight, the edge of physics. But to a theorist, it looks suspiciously like the description of being sealed inside an event horizon. This isn't a brand new suspicion. In the mid-20th century, physicist Igor Novikov mused about the possibility of universes born inside black holes. Others extended the thought, noticing that the math describing a closed universe rhymes neatly with the math describing a black hole interior. Historians debate whether they were serious or just playful, but playful speculations have a way of becoming physics. Consider this quirky detail. In the 1960s, theorist Nikodem Pavlovsky proposed something audacious, that every black hole might be a gateway to a new universe. And perhaps our own Big Bang was one such gateway, an aftershock of collapse in a parent cosmos. Imagine that! All of this, galaxies, Earth, your quiet heartbeat tonight, could be unfolding inside the belly of a star that died billions of years ago, in a realm you will never touch. What makes the idea seductive is symmetry. From the outside, a black hole is collapse, matter pulled inward, horizons shrinking. From the inside, relativity allows the coordinates to flip. Inward can feel like outward. Collapse can look like expansion. That's exactly what our universe seems to be doing, expanding from a fiery birth. To us, galaxies rush away. To an observer outside, it might all be falling inward. Same reality, two descriptions, one cruel joke of perspective. But the picture gets tangled. If our universe is inside a black hole, where's the singularity? Where's the crushing core? Some cosmologists argue that what we call the Big Bang was that singularity, hidden from view by the event horizon we live within. To us, it looks like a universe expanding for 13.8 billion years. To an outsider, it might look like matter collapsing in a parent universe's black hole. From inside, forward feels like expansion. From outside, forward looks like collapse. Reality loves symmetry. And the implications stretch wider. If universes can exist inside black holes, then every black hole in our universe might cradle another cosmos within it. Not just a few, millions, maybe billions of bubble realities budding inside the invisible guts of collapsed stars. Universes inside universes, stacked endlessly, a cosmic nesting doll without bottom or top. But not so fast. Physics doesn't give its wonders freely. The cosmic microwave background, the faint afterglow of the Big Bang, matches predictions from an expanding universe, not a collapsing star. Many physicists take this as a fatal blow to the black hole universe idea. Others counter that our understanding of quantum gravity is incomplete, and that new rules may be waiting in the gaps of our math. Here's your light-hearted kicker. Imagine explaining this to your great-great-grandmother. Yes, Grandma, everything you've ever known, every church, every market, every sunrise, actually happened inside the belly of a dead star in another universe. She'd likely shake her head, mutter that you've been reading too much pulp magazines, and serve you soup. But remember, her own grandparents believed Earth was the center of the universe. Strange ideas age into common sense. So tonight, as you settle deeper into your blanket, remember, you're not just lying on Earth, inside the Milky Way, inside the observable cosmos. You might be curled up on the soft floor of a black hole's hidden chamber, dreaming beneath its vast, invisible ceiling.
You've probably heard the comforting story that the universe stretches on forever, boundless, infinite, limitless. But what if that's not true? What if everything, every galaxy, every particle, every fleeting thought wasn't sprawled across infinite space, but locked inside a colossal black hole so vast you can't even perceive the bars of its cage? It sounds like science fiction, something scribbled by a physicist at 3 a.m. on the back of a napkin. And yet this idea that the cosmos itself might be a black hole has been whispered about in physics circles for nearly a century. What makes it compelling is that math doesn't forbid it. In fact, the math teases it. Let's rewind to 1939. Robert Oppenheimer, the same man later called the father of the atomic bomb, worked with his student Hartland Snyder to explore what happens when a massive star collapses. They concluded that such a collapse would inevitably form what we now call a black hole, an object so compact that not even light could escape. Their paper was about stars, but buried inside the math was something more universal. The same equations hinted that any region of space-time, if enclosed by a horizon, could behave the same way. Scale it up, and suddenly you're looking at something disturbingly like an entire universe. By the mid-20th century, cosmologists like Georges Lemaitre were already describing the universe as expanding from a primeval atom, a dense, hot initial state. Meanwhile, Soviet physicists like Igor Novikov began to ask a dangerous question. What if this expansion is just what the inside of a black hole looks like from within? Pause on that. From the outside, a black hole is collapse, a one-way plunge toward a singularity. But from the inside, the math says something different. The interior of a black hole doesn't feel like a pit. It feels like a dynamic, expanding space-time. In other words, from your perspective, it might look exactly like a universe blowing itself wide open in a big bang that never stops. That's the seductive symmetry. The equations of general relativity don't simply allow this possibility, they almost demand it. Imagine the universe as a baby birthed by a parent black hole. Somewhere out there in a higher dimensional reality, a collapsing star pinched space-time into a bubble, and that bubble bloomed into the universe you inhabit. Everything you know, galaxies, planets, you, could be unfolding because of a collapse that happened in a cosmos beyond your reach. If that's true, then every black hole in our universe might be repeating the trick. Each one a womb, each one a seed. Inside them, new universes might already be flowering, with their own physical laws, their own galaxies, maybe even their own conscious beings asking the same late-night questions you're asking now. Cosmologist Lee Smolin took this idea further in the 1990s. He proposed cosmological natural selection, the idea that universes that produce more black holes reproduce more often. Over time, universes evolve toward the physics that make them fertile with black holes. Not by design, not by miracle, but by sheer reproductive success. By that logic, our cosmos might be here not because it's special, but because it's prolific at making black holes. Others speculated about white holes, the mirror image of black holes. Where black holes swallow everything, white holes expel matter and energy. A white hole looks a lot like a Big Bang, which leads to the wild thought, maybe every Big Bang is the mouth of a white hole on the far side of a black hole's collapse. Death here, birth there, a cosmic conveyor belt of collapse and creation. Of course, mainstream physics urges caution. These scenarios stretch relativity beyond where it can be trusted. Singularities, the infinite points at the centers of black holes, are signs that the equations have broken down. To know what really happens, we need quantum gravity, a theory that merges the large and the small, Einstein's smooth curves with the jitter of quantum mechanics. And that theory doesn't exist yet. But the allure remains. The parallels are too sharp to ignore. Both black holes and the cosmos have horizons, boundaries beyond which nothing can reach us. Both involve entropy, the measure of disorder that grows with surface area. Both carry the weight of mystery, an inside unseen, an outside unreachable. So here's the picture. You're lying beneath the night sky, staring at stars that seem infinite. But from the outside, it might look different. The entire universe, all of it, could appear as a sphere of darkness, a black hole floating in some higher dimensional reality. You'd never know. From within, it looks endless. From without, it looks sealed. And the questions follow, questions that drift toward philosophy. If every black hole births a universe, are we just one link in an infinite chain? If universes evolve through collapse, what does that say about meaning or purpose or design? Perhaps creation itself isn't divine, but recursive, a cosmic cycle of wombs and tombs, forever looping. The truth is, no one knows. Physicists argue, equations tease, evidence hides. And yet, the story won't die. Why? Because it isn't just math. It's a myth wrapped in mathematics. A story where endings are beginnings, where collapse is birth, where the black hole isn't a grave, but a cradle. And the haunting twist is this: if the universe really is a black hole, then every experiment, every theory, every thought you've ever had is already happening inside the belly of the beast. When you study black holes, you may be staring at reflections of the very structure you already inhabit. So you're left with a question not just of physics, but of lineage. If black holes give birth to universes, what will our black holes create long after we're gone?
You've circled the idea long enough. If the universe truly is the inside of a black hole, then the real mystery is this: what does it actually mean to live inside an event horizon? What would you notice, if anything, as you carried on with your ordinary life? The first unsettling truth is that you wouldn't notice much at all. Event horizons don't feel like walls. They're not fences or glowing shells. Crossing one doesn't trigger alarms. It's just another moment, another heartbeat. If you drifted across the event horizon of a stellar black hole, you wouldn't feel a sudden bump or barrier. You would simply keep moving forward. To you, life would feel normal. To the rest of the universe, though, you'd already be gone. That's the first strange feature of horizons. They divide realities. Inside, time and space twist. Outside, your signals stretch and fade. Observers beyond the horizon never see you fall in completely. They see you slow, stretch, and vanish into red light. You, on the other hand, don't feel slowed. You keep falling. Two descriptions of the same event, equally valid, yet irreconcilable. Now scale that up. Imagine that you, right now, are already living inside such a horizon. The cosmic horizon marks the edge of what you can see. Beyond it, galaxies exist, but their light will never reach you. To you, they are gone, unreachable. You live in a bubble of the visible. From within, that feels infinite. From beyond, if there is a beyond, it might look like the sealed interior of a black hole. And the deeper you let yourself imagine, the stranger it becomes. Inside a black hole, space and time switch roles. Time no longer carries you forward toward tomorrow, it carries you inward toward the singularity. The singularity isn't just a place, it's your future. Every tick of your clock, every breath you take, brings you closer to it. You don't travel to the center, you age into it. The fall is not optional, it is the very definition of your timeline. If that's the case, then what we call cosmic expansion might actually be this inward march. Galaxies flying apart from one another could simply be the way falling inward feels from the inside. Our fate isn't outward acceleration, but inevitable collapse. The horizon tricks us with its perspective. This is where the paradoxes begin to bite. In classical relativity, information that falls into a black hole is lost forever, gone from the universe. But quantum mechanics insists that information can never be destroyed. This clash between the two is what Stephen Hawking called the information paradox. And if our entire universe is the inside of a black hole, then this paradox isn't just about distant stars, it's about everything you know. Is all the information about your life, your choices, your history, destined to vanish into a singularity? Or is it somehow preserved and coded on the horizon itself like an invisible ledger? That's where the holographic principle enters the scene. Proposed in the 1990s, it suggests that everything happening inside a black hole, the entire three-dimensional reality experienced by someone like you, can be described by information encoded on its two-dimensional surface, like a hologram. Which means that if the universe is inside a black hole, then maybe your life, your memories, your dreams are all shadows projected from data on a far-off cosmic horizon. The stars above you are not just distant, they might be reflections, shimmering copies of something deeper. It sounds absurd, but the math supports it. Black hole entropy, the measure of its hidden information, grows with surface area, not volume. A black hole the size of the universe could store all the information required to describe your reality. In that picture, you're not lost in the abyss, you're inscribed on the walls. Still, living inside a horizon is unsettling. From within, everything feels smooth. No alarms, no boundaries, just the illusion of infinite freedom. From without, you're sealed, cut off, doomed to collapse. It's like living in a glass dome so vast you mistake it for the sky. You never see the edge, but it sees you. The most haunting part is how normal it feels. Stars still burn, coffee still brews, children still laugh. Nothing in your day suggests that you're already trapped. And yet, according to some interpretations of the math, that's exactly what's happening. You're not waiting to fall into a black hole someday in the distant future. You're already inside one now. And so the question sharpens once more, pricking your thoughts as you lie awake. If existence itself is already bound within an event horizon, then what lies ahead? Where is this fall carrying you?
Gravity doesn't just bend space, it bends time. That's the part that unsettles you most as you lie there, drifting deeper into thought. You can imagine space curving around a planet like fabric sagging under weight. But time? That's harder. And yet, inside a black hole, time doesn't just bend, it traps you. Einstein's equations whisper a cruel truth. The closer you move toward an event horizon, the slower your clock ticks relative to someone farther away. Sit at the edge of a black hole, and you might live minutes, while the universe beyond ages billions of years. You become a ghost of time, a relic stretched thin against eternity. Now imagine this not as a local phenomenon, but as the entire structure of reality. What if our universe is not merely inside a black hole, but also under its time law? That would mean what we call cosmic history, the 13.8 billion years since the Big Bang, isn't an ordinary timeline at all. It's the slow unfolding of collapse, a stretched descent into a singularity we cannot yet see. This is why physicists talk about cosmic time dilation. To an outside observer, if such an observer exists beyond our universe, everything happening here might look brief. What feels like billions of years to you might be the blink of an eye to them. From their perspective, our universe is just a flash of collapse. From ours, it's an epic story, written slowly, lovingly, galaxy by galaxy. Here's the trap. You can't tell the difference. To you, days unfold in their ordinary rhythm. You boil water, wait for tea to steep, sigh as the kettle cools. Nothing suggests that your entire reality is ticking under a different law. You are wrapped in time's blanket, but the blanket is not the same as freedom. It's more like a cocoon. And black holes make this cocoon inescapable. Once you're inside, the direction of time itself changes. You don't fall toward the singularity because gravity pulls you. You fall because time now is the singularity. Moving forward is moving inward. That's the cruel genius of the trap. You cannot choose otherwise. Every heartbeat is a step closer. But here's where comfort sneaks in. If this is true, then you've been falling all along, since the moment of your birth, since the universe's first flicker of light. And yet, life still blooms, suns still rise, children still play in parks, oblivious to cosmic traps. The fall doesn't erase beauty, it simply frames it. A firefly still glows even as the night deepens around it. Physicists sometimes describe this with metaphors of waterfalls. Imagine a fish swimming in a river. The water flows faster and faster, carrying it along. Far upstream, the fish doesn't notice. But closer to the falls, the water accelerates until even the fastest swimmer cannot escape. That's what space-time does near a black hole. That's what time might be doing in your universe, dragging you forward faster than you realize toward a horizon you'll never see. The strangest part is that cosmic expansion might be nothing more than this fall in disguise. When astronomers measure galaxies racing away, when they say the universe is not just expanding but accelerating, maybe what they're really glimpsing is the geometry of time under a black hole's rule. Falling inward can look from the inside like rushing outward. Collapse and expansion, two sides of the same current. The paradox burns brightest here. If information is lost to singularities, then your life, your words, your loves, your struggles may one day vanish without trace. But if the holographic principle is right, then everything is preserved on the horizon, etched forever into space-time's skin. From that perspective, you're not disappearing. You're being written into the universe's very surface, a cosmic diary that never closes. So, which is it? Oblivion or permanence? No one knows. That's the slow trap. You live your entire life inside a riddle without an answer. To you, it feels ordinary. To the equations, it's extraordinary. And yet, there's a certain comfort in this. Because if time is a slow fall, then the very act of living, laughing, loving, drifting off to sleep tonight is part of the great descent. You are not apart from the black hole. You are the fall itself. And in that thought, oddly enough, there's peace. The trap isn't a prison, it's the river. And rivers carry you, whether you fight or float.
By now, you've followed the river far enough to realize black holes aren't just strange objects, they are paradox machines. Every time physicists think they've tamed them with equations, the holes spit back contradictions sharp enough to split science in two. And if you're truly inside one already, those paradoxes aren't distant puzzles. They're the rules of the world you live in. The most famous paradox is the one Stephen Hawking gave his name to. In the 1970s, he shocked the physics world by showing that black holes aren't perfectly black. Quantum effects at the event horizon allow them to emit a faint glow, what we now call Hawking radiation. Over time, this radiation makes the black hole shrink, then vanish. That's fine on its own, but here's the paradox. If a black hole disappears, what happens to the information that fell in? Quantum mechanics insists information can never be destroyed. General relativity seems to say it vanishes forever. When Hawking first published his result, he declared that information really is lost, which meant quantum theory, our most precise, reliable description of reality, was incomplete. The physics community didn't forgive him easily. Decades of debates followed, fierce enough to divide careers. By the time Hawking softened his stance, the damage had been done. The paradox refused to go away. Now hold that thought up against your universe. If this cosmos is the interior of a black hole, then what happens when the parent hole evaporates? Does our entire reality wink out like steam off a pond? Or does the information of galaxies, stars, and people remain encoded somehow on the horizon? Are you temporary or eternal in disguise? That leads to the next paradox, the firewall problem. In classical relativity, crossing the event horizon should feel uneventful,
Smooth, ordinary, you'd drift across without bump or blaze. But in some interpretations of quantum mechanics, the horizon could be a literal wall of energy, a blazing firewall that incinerates anything trying to pass through. Two perfectly logical descriptions, two utterly incompatible outcomes. Which one is true? The universe doesn't tell you. It hides its answer behind the veil. And then there's the singularity itself. The core of a black hole is supposed to be infinitely dense, infinitely small. But infinities in physics are red flags, signals that the equations have broken down. Relativity says the singularity exists. Quantum theory says it cannot. Somewhere between the two, a deeper theory of quantum gravity must exist, but no one has found it yet. Until they do, the heart of the black hole remains not just mysterious, but impossible. Now remember, if we are inside such a structure, all these paradoxes apply to us too. Maybe what we call the Big Bang singularity isn't a beginning at all, but just the inside view of collapse from somewhere else. Maybe what we call expansion is an echo of evaporation. Maybe the laws we think are permanent are only temporary bandages hiding contradictions. And still, there's the holographic principle lurking in the background, whispering its eerie comfort. According to this idea, everything inside a black hole, the whole three-dimensional drama, can be described by data encoded on its two-dimensional surface. Which means if the universe is a black hole, then you are already written on its horizon. You are a pattern of information woven into the fabric of space. You cannot be erased, only transformed. That's the paradox inside the paradox. Annihilation and permanence, both claimed at once. You are dust fated to vanish, and a hologram fated to endure. You are temporary and eternal, depending on which law wins the argument. And so, as you let the thought wash over you, you realize why physicists keep circling black holes like moths around a flame. They are not just astrophysical objects. They are reality tests. They are the questions we can't stop asking. If we can solve black holes, we can solve the universe. If we can't, then maybe the universe itself is unsolvable. And you, living, breathing, lying under the ceiling of night, are caught in the middle. A paradox in human form, inside a paradox of cosmic scale.
You've reached the point where the universe starts to feel less like a place and more like a puzzle box. And the puzzle's core is this. If we really are inside a black hole, then everything, every tree, every city, every breath, might not be quite what it seems. It might all be encoded somewhere else, painted on the cosmic horizon like a secret script you'll never see directly. This is the holographic principle. At first glance, it sounds like New Age poetry, but it comes from physics, from attempts to solve the black hole information paradox. In the 1990s, physicists Jared Tooft and Leonard Susskind proposed that the three-dimensional contents of a black hole could be described entirely by data inscribed on its two-dimensional boundary. It's like walking through a room, touching the walls, breathing the air, living in depth, only to find out later that everything you experienced was the projection of patterns on the room's wallpaper. If that principle holds, then our entire universe might be a hologram. Every memory you have, every decision you make, might already be encoded on a surface you'll never touch, the cosmic horizon. You are not in the universe in the way you think. You are on it, written into its edges, a shadow pretending to be flesh. The unsettling part is how well this idea fits the math.
Black hole entropy, the measure of how much information a black hole can hold, grows with the surface area of the horizon, not its volume. That's backwards from intuition. You'd think the bigger the inside, the more room there is for information. But no, nature seems to store reality on the skin, not the guts. So if the universe is a black hole, the same rule may apply. What you call inside is just a clever trick of perspective. The truth is on the edge. Some versions of string theory back this up. Juan Muldacena's famous ADS-CFT correspondence suggested that a higher dimensional space with gravity could be perfectly described by a lower dimensional space without gravity. Translation: a world like ours could be a holographic projection of data scribbled on a cosmic screen. You think you're living in 3 dimensions, but you're actually a 2-dimensional script unfolding in disguise. It's not just science fiction anymore. Physicists have run calculations using this holographic model, and in some cases, the math works out better than standard approaches. It predicts behaviors that otherwise look mysterious. It explains why black holes don't erase information. It ties together threads of quantum theory and relativity that usually snarl and fight. It feels, in short, like the universe is leaving us hints about its true architecture. And if you are living inside such a projection, what does that mean? It means the stars above you aren't simply scattered in space. They're part of a pattern, like dots in a code. Your body isn't just atoms arranged by chemistry. It's information arranged by geometry. You aren't in the cosmos. You are of the cosmos, woven into its script. But here's the twist. The holographic principle doesn't make life less real. It makes it differently real. Think of a photograph. The image you see is flat, but the light encoded on it convinces your eyes of depth. The subject once stood in 3 dimensions, and the photo captures its essence. In the same way, the universe as hologram might not strip meaning from your life. It might instead mean your existence is part of a deeper order, an order written in the most efficient language knows: information. And that's where the poetry sneaks in. If the universe is a hologram, then you are not simply vanishing dust. You are a line of code on the edge of infinity, preserved as long as the horizon endures. The fall into the singularity might not erase you. It might simply rewrite you. Still, the paradox lingers. If all information is preserved, why does it feel like life is fleeting? Why do memories fade? Why do stars die? Why do galaxies drift into darkness? Maybe because what you experience here is not the archive itself, but the performance. The archive is safe, etched on the horizon. You, meanwhile, live inside the unfolding story, and every story must have change, conflict, and eventually an ending. And so you find yourself caught between comfort and unease. Comfort, because the holographic principle suggests permanence, that nothing is truly lost. Unease, because it means what you see, touch, and trust may not be the fundamental truth. You are both shadow and substance, both projection and participant. As you let the thought settle, a strange calm follows. Because whether you're a hologram or not, you still laugh, you still dream, you still breathe. And maybe that's the point. The projection is enough. The hologram is still beautiful. If black holes are traps, inescapable one-way doors into darkness, then white holes are their strange mirrored twins. The idea first surfaced in the mathematics of relativity, lurking in the equations like an overlooked shadow. Where a black hole swallows everything, a white hole does the opposite. It spits everything out. Nothing can enter, nothing can stay. Matter and energy pour outward in a relentless stream. At first, white holes sounded absurd, more like mathematical pranks than physical objects. No one had ever seen one, and none are expected to exist in the ordinary sense. But then the thought arrived. What if the Big Bang, the birth of the universe itself, was a white hole? Pause on that. A black hole in one universe could collapse into a singularity. From the outside, it looks like an ending, a final gulp. But from the inside, if you flip the coordinates, it could feel like a burst of expansion, a beginning. In other words, the birth of a universe might be indistinguishable from the explosion of a white hole. Death here, birth there. It's innate symmetry, and nature seems to love symmetry. Black holes consume, white holes eject. Every action is balanced with its opposite. So maybe our Big Bang wasn't the origin of everything, but simply the other side of collapse in a parent cosmos. A chain of rebirths stretching back into unknowable time. The Russian physicist Igor Novikov explored this possibility decades ago. Later, Nikodym Poplavsky took it further, suggesting that every black hole could generate a new universe beyond its horizon. In this view, universes are born constantly, each tucked inside the heart of another. Your universe, your galaxies, your life. Just one leaf in an infinite forest of cosmic rebirths. It's dizzying to imagine. A star collapses. Its core shrinks into a black hole. To its own universe, the story ends. But inside, the collapse blooms outward as a Big Bang. A new universe forms, with its own physics, its own galaxies, maybe its own version of you, lying awake under a foreign sky, wondering the same impossible questions. And if this is true, then the universe itself is never still. It's a tree, endlessly branching. Every black hole a seed. Death is never the end, only a door. That's not just poetic, it's a mathematical possibility. But the idea isn't without problems. For one, no one has ever observed a white hole. They remain hypothetical, untested, a mathematical mirror image without physical evidence. For another, if our universe is a white hole, then why does it look so smooth, so orderly in its early stages? White holes, by definition, should spew matter chaotically. Yet the cosmic microwave background shows astonishing uniformity, like a perfect fog spread evenly in every direction. If the universe is a rebirth, it's a strangely calm one. Still, the thought persists. Because when physicists trace the arrow of time backward, when they wind the cosmic clock to zero, they end up with something like a white hole. All matter, all energy, compressed into a singular point, then unleashed in an instant of expansion. A one-time eruption that looks suspiciously like the mathematics of a reversed black hole. And here's the philosophical rub. If every black hole births a new universe, then perhaps the act of creation is not rare at all, but inevitable. Not a divine spark, not a cosmic accident, just the ordinary consequence of collapse. Creation and destruction become two sides of the same law, inseparable. That realization carries weight. It means that the cosmos doesn't need outside intervention to renew itself. It renews constantly, automatically, endlessly. Your universe might not be the first. It might not be the last. It might just be one heartbeat in a cycle too vast to ever end. You let that settle into your thoughts. The idea that every death carries a hidden birth, that endings are illusions, disguises for beginnings, that collapse isn't failure, but transformation. And so you drift between unease and comfort. Unease because it means your entire universe might be the child of some dying star, born in a cosmic catastrophe you'll never see. Comfort because it means nothing is truly lost. The cycle continues. The cosmos breathes. Perhaps that's why the night feels eternal, why the stars above you carry both silence and promise. They're reminders that collapse and rebirth are not opposites. They are the same story, told from two perspectives. And if you are already inside a black hole, then maybe, just maybe, your universe's own rebirth is waiting somewhere ahead. A horizon you'll never reach. A singularity that one day blossom out into another sky, another story, another you. If every black hole can give birth to a new universe, then the night sky isn't just sprinkled with stars, it's seeded with wombs. Each one a hidden passageway, each one a silent nursery. And suddenly, the idea of the multiverse stops being abstract philosophy and starts being practical. The multiverse usually shows up in two flavors. One is the quantum version, where every possibility spawns a new reality. Every coin toss, every choice, every quantum event splits into branches. Somewhere, there's a version of you who never moved away from home, another who never made it through childhood, another who lives on a world where dinosaurs never went extinct. That's the wild, many worlds interpretation of quantum mechanics. But the black hole multiverse is different. It isn't about branching at every choice, it's about generation at every collapse. Every black hole in every galaxy could be a gateway to a new universe, with its own constants, its own physics, its own timeline. You're not just living in a universe, you're living in a genealogical tree, a lineage of cosmoses breeding through collapse. Physicist Lee Smolin spun this into something radical: cosmological natural selection. Universes that are better at making black holes give rise to more offspring. Over countless generations, universes evolve toward the physics that maximize black hole production. Which means your universe isn't an accident, it's successful. It survived the great evolutionary game, not because it's tuned for humans, but because it's fertile with black holes. That flips the script on the so-called fine-tuning problem. Scientists often marvel at how perfectly balanced the universe's constants seem to be. Gravity, the speed of light, the strength of electromagnetism, all just right for stars to form, for chemistry to flourish, for life to exist. To some, that suggests design. To others, luck. But through the black hole lens, there's another option. Our universe looks tuned not for life, but for reproduction. Life is incidental. Black holes are the true legacy. And that thought is humbling. You and I, every living creature, every cathedral and concert, every tragedy and triumph are side effects, not the main event. Just byproducts of a cosmos whose real purpose, if we can even use that word, is to collapse into seeds that bloom into new universes. But then something comforting creeps in, because if the multiverse is real, if every black hole births another cosmos, then nothing truly ends. Not galaxies, not even universes. Every fall is a birth. Every death carries continuity. And maybe, just maybe, life will flicker somewhere again. Perhaps not you, perhaps not me, but somewhere, some version of awareness may arise, staring at some alien sky, asking the same unanswerable questions. The perspective is dizzying. Imagine lying under the stars, knowing each one of those pinpricks may hide a portal. Behind the black veil of its collapse, a new reality might already be unfolding. Right now, as you breathe, universes could be budding in silence, invisible to you, yet as vast and intricate as your own. Of course, mainstream physics treats this with caution. Evidence is elusive. We cannot peer inside black holes to confirm what's there. We cannot reach outside our own universe to compare. We are prisoners of our horizon, speculating in the dark. But then again, wasn't every breakthrough in science once speculation? Atoms, relativity, quantum fields, all once dismissed as impossible until they weren't. And here's the irony. If this vision is correct, then your universe is both ordinary and extraordinary. Ordinary because it's just one among countless others. Extraordinary because from your vantage point, it contains everything. To you, it is everything. A paradox of perspective. So tonight, as you drift toward sleep, let yourself imagine it. Universes as a forest, black holes as seeds, reality as a self-perpetuating cycle of collapse and creation. A multiverse not scattered but nested, each universe tucked within another's heart. And maybe, just maybe, the questions you whisper to the dark aren't yours alone. Perhaps in some other universe, born of some other black hole, another mind is whispering the same words right now, wondering if they too are already inside.
Every story has an ending, and if the universe is the inside of a black hole, then so does ours. You can't avoid the question forever: what happens at the end of time? The simplest picture is grim. In classical relativity, all paths inside a black hole lead inevitably to the singularity. No matter how you move, no matter how fast you flee, time itself drags you inward. The singularity isn't a destination you might dodge. It's the definition of your future. Every galaxy, every planet, every breath you take, all rushing slowly but inexorably toward the same final point. From this view, the fate of the universe is collapsing. What looks like cosmic expansion, galaxies racing apart, dark energy driving acceleration, might just be the inside perspective of that fall. To us, it feels like outward growth. To an outside observer, if such a thing exists, it might look like it collapsed into the core of a larger black hole. Expansion and contraction, two interpretations of the same geometry. But there are other possibilities. Hawking radiation teaches us that black holes evaporate. If our universe is inside one, then one day, trillions upon trillions of years from now, the parent black hole could shrink and vanish. What would that mean for us? Would our universe flicker out like a candle, its information smeared across the cosmic horizon? Or would the evaporation itself look from our side like some strange new phase of reality, an ending disguised as transformation? Physicists have imagined several scenarios for the far future. One is the heat death of the universe. Stars burn out, galaxies drift into darkness. Black holes themselves evaporate into faint radiation. Time stretches toward infinity, but nothing new happens. No structure, no spark, just silence. An endless desert of low-energy emptiness. Another is the Big Crunch. If gravity eventually overcomes expansion, the universe could reverse its growth, collapsing back into a singularity. In that case, the end looks like the beginning in reverse. Everything converging to a point, heat rising to infinity, time narrowing to nothing. Some have speculated that such a crunch could seed a new Big Bang, a rebirth through destruction, echoing the cycle of collapse and creation. And then there's the Big Rip.
If dark energy keeps accelerating the expansion, galaxies won't just drift apart, they'll be torn away from each other. Eventually, stars themselves will be ripped from galaxies, planets from stars, molecules from planets, atoms from molecules. Even space-time itself could shred into nothing. A universe pulled apart thread by thread until there's no fabric left at all. Each of these fates is chilling in its own way. Eternal stillness, violent collapse, cosmic dismemberment. None of them are comforting, not if you stare too long. But each of them also fits the black hole narrative. Heat death is evaporation. The big crunch is collapse. The big rip is the shredding of the horizon. Different endings, perhaps the same inevitability. And still a whisper of hope lingers. If black holes can birth universes, then endings might always be beginnings in disguise. The singularity at the end of time may not be a final stop, but a doorway. What looks like death here could be birth elsewhere. Just as your universe might have blossomed inside another, so too might another blossom after yours. The philosopher's question then isn't if the universe ends, but what kind of ending it is. A silence, a rebirth, a passage. And what does it mean to live knowing you are carried toward that horizon with every breath? You shift slightly under the blanket. The night feels heavier, but not hopeless. Because if the fall is inevitable, then maybe meaning isn't in escaping it. Maybe meaning is in noticing it, in loving within it, in being a spark that glows brightly even as the river carries you toward the sea. And perhaps the fate of the universe isn't something to fear, but something to honor. A reminder that even the cosmos, vast as it is, follows rhythms. Life, death, rebirth. Even galaxies are not exempt from the cycle. And if that's true, then you, small, fragile, fleeting, are simply part of the same rhythm. You breathe in slow. You breathe out slower. The end of time is coming, yes, but so is tomorrow morning, and both are worth noticing.
By now, the paradox is undeniable. If the universe is the inside of a black hole, then you are both trapped and free, both doomed and eternal, both shadow and substance. And somehow, both answers feel true. On one hand, there's no escape. If reality really does sit behind an event horizon, then your fate is bound. You're not strolling across infinite landscapes, you're drifting inside a sealed chamber. Every galaxy, every atom, every future moment is contained. The horizon is your boundary, the singularity your destination. You are a prisoner without chains. But on the other hand, the holographic principle whispers something gentler. Information is never lost. You are inscribed on the cosmic surface, encoded into the very geometry of reality. Even as you vanish, you endure, not in the way you want, not as flesh, not as memory, but as a pattern, as information that cannot be destroyed. That's the paradox you live in, annihilation and preservation at once. An end that is also a continuation, a horizon that is also a mirror, a prison that is also a womb. The truth is, this paradox isn't just cosmic, it's human. You've always lived inside contradictions. You are fragile yet stubborn, fleeting yet desperate for permanence. You fear endings, yet you cannot resist beginnings. The universe's riddles are simply reflections of your own. Consider time.
You know your hours are limited. You know one day the river carries you under. And yet, you live as though tomorrow is certain, as though meaning is possible in the middle of the fall. That's not ignorance, that's defiance. Or maybe it's wisdom. Consider freedom. If the universe is inside a black hole, your movements are predetermined. No escape, no way out. And yet, within those constraints, you love, you laugh, you write, you dream. A bird inside a cage still sings. A flame inside a lantern still glows. Freedom isn't the absence of boundaries, it's the ability to burn brightly within them. And consider meaning. If life is just information playing itself out, a hologram written on the horizon, then maybe meaning is illusion. Yet illusions sustain you. The warmth of a hand, the ache of longing, the beauty of a sunrise. None of those change if the universe is projection. Meaning doesn't need to be ultimate to feel real. Sometimes the story is enough. Physicists circle these paradoxes, trying to solve them with equations. But you don't need equations. You live the paradox already. You are fragile but enduring, insignificant but miraculous, small but vast enough to imagine the cosmos itself. And that's the real trick. Whether the universe is infinite or trapped inside a black hole, whether information is preserved or lost, whether endings are final or beginnings in disguise, you are here now thinking about it. And that makes you part of the paradox, not just a victim of it. So how do you live in the paradox? You accept both sides. You let endings remind you of beginnings. You let fragility deepen your appreciation of each moment. You let the thought of collapse sharpen your love for the small, bright things. The laughter of a friend, the quiet rhythm of rain, the simple act of breathing in the dark. Living in the paradox doesn't mean solving it. It means resting in it, allowing both truths to sit beside each other without canceling out. You are mortal and eternal. You are bound and infinite. You are falling and you are flying. And tonight, as you lie under the sky, whether it's truly open or merely a painted ceiling, you can let the paradox rock you like a lullaby, not as a riddle to solve, but as a reminder that mystery is its own form of beauty. Because maybe the universe doesn't need you to solve it. Maybe it just needs you to notice it, to live inside its contradictions fully, honestly, awake. And now we arrive at the quiet part of the journey, the place where questions soften, where the edges blur, where paradox gives way to something more like peace. You've wandered through black holes and horizons, through equations and paradoxes, through beginnings that are endings and endings that are beginnings. But as night presses in, as your breathing slows, you find yourself asking, what does it all mean for you, here, now? Maybe the answer is simple. Maybe the truth is that you've always been inside. From the moment of your first breath, from the moment the universe cracked open in its great eruption of light, you were already within the horizon, not falling into a black hole, not circling its edge, but living your entire existence in its hidden interior. The stars above you are not the ceiling of freedom. They are the painted walls of a cell, so vast you mistake it for infinity. But that isn't meant to frighten you. Quite the opposite. Because the cell is beautiful. Look around you. Galaxies unfurl like frozen fireworks. Gravity builds worlds of astonishing delicacy.
Life emerges, sings, loves, dreams. You are part of that beauty, a flicker of awareness that the cosmos grew out of its own hidden mathematics. And if this is all a hologram, if you are written on the horizon, etched into space-time's skin, then that means you are permanent in ways you cannot yet understand. Not as a body, not as thought, but as information. The universe has recorded you, and nothing can unwrite it. Even if the black hole evaporates, even if horizons shrink and singularities bloom, the record of your existence remains woven into the cosmic story. So here's the paradox one last time. You are fragile and you endure. You are falling and you are flying. You are inside a prison that is also a cradle. And perhaps that's the deepest truth the black hole can teach you. Not about endings or beginnings, but about the coexistence of both. The philosophers of old used to whisper that we live in a shadow world, that reality is a reflection of something deeper. Plato's cave, shadows dancing on the wall. The Vedic seers of India speaking of Maya, illusion draped over truth. Today, physicists with chalk dust on their hands find themselves whispering something similar. Maybe reality is a projection. Maybe everything you see is inscribed on a horizon you cannot reach. Different languages, same haunting intuition. And yet, even if it's projection, even if it's illusion, even if you are nothing more than code painted on the universe's edge, doesn't it still feel real? The laughter of a child, the sound of rain against glass, the weight of someone's hand in yours, real enough to ache for, real enough to cherish. So you close your eyes now, and you let the paradox rest. You don't need to solve it tonight. You don't need to decide whether you are free or trapped, eternal or fleeting, shadow or substance. You only need to notice the mystery and allow it to hold you, gently, like gravity's blanket. What if Earth is already inside a black hole? Maybe it is. Maybe it always was. And maybe the answer doesn't matter. Because inside or outside, projection or not, the universe has still given you the gift of a night sky. And tonight, that is enough. Drift now. Let the stars blur. Let the questions soften. The horizon will hold. The paradox will keep. And you, small as you are already part of the dream. Good night.